Welcome to the Explainer. So, today we're going to challenge a deeply held assumption that, well, almost all of us share. We tend to look around at our home planet Earth and just think, this is it. This is absolutely the peak paradise for life in the universe. But what if I told you Earth is actually kind of mid? Seriously. When you truly look at the numbers, a massive portion of our so-called paradise is incredibly hostile to life. We're going to explore what a truly perfect world would look like, and honestly, how it makes our home look pretty bleak in comparison. Okay, so we all know that our oceans cover the vast majority of Earth's surface, right? But here is a shocking reality that we rarely actually think about. 95% of that ocean water exists in complete, permanent darkness. The light from our sun simply cannot penetrate the water deep enough. So literally only a tiny 5% sliver at the very top of the ocean gets any sunlight at all. Because of that, we need to entirely reframe how we view our oceans. We've got to stop thinking of them as this boundless, welcoming haven for life from top to bottom. That 95% of dark water, it's effectively an abyssal desert. It is freezing cold, the pressure is violently crushing, and it's just a barren, hostile environment compared to what's actually possible. Earth really isn't the ideal baseline for marine life. It's a world overwhelmingly dominated by a pitch-black void.
Section 1. Designing a Superhabitable Planet.
So, if Earth isn't the perfect canvas for life, what exactly is? Well, exoplanet researchers have modeled the ultimate theoretical world. We're talking about a planet specifically engineered from the ground up to be the absolute best possible home for life in the universe. We're going to call this theoretical world Hestia, named after the Greek goddess of the hearth and home. And Hestia's perfection starts long before you even reach the planet's surface. It starts with its sun. You see, Earth orbits a yellow dwarf star. It's fine for now, but yellow dwarfs keep getting hotter as they age, and they die out in less than 10 billion years. In fact, roughly 70% of Earth's habitable window has already passed. Yipes. Hestia, on the other hand, orbits an orange dwarf. These stars are the true Goldilocks of the cosmos. Their energy output is incredibly stable, and they live for up to 70 billion years. That gives life an unbelievably long, secure runway to emerge, evolve, and just continuously thrive without the ticking clock of a boiling star.
Section 2. Oceans without any darkness.
To build a truly superhabitable world, we have to fix the absolute biggest flaw of our home planet. We have to completely eliminate the abyss. On Earth, the average ocean depth is a staggering 3,700 meters. That massive, isolating depth is exactly why the light can't reach the bottom. But on Hestia, the oceans are structurally designed to be completely different. They're incredibly shallow. Hestia's average ocean depth is only between 100 and 200 meters. Essentially, Hestia just doesn't have those deep, isolating ocean basins. Its global ocean is almost exclusively made up of shallow continental shelves. Now, you might be wondering, why does that shallow depth matter so much? Well, it all comes down to the sunlight zone. On Earth, this is just that upper 200 meters where light actually penetrates. In biology, this light is absolutely everything. It is the engine of life. It allows plankton to turn sunlight into sugar, which forms the vital basis for the entire marine food web. Because Hestia's oceans are only 100 to 200 meters deep at maximum, the sunlight hits the ocean floor everywhere. That means 100% of Hestia's ocean is a sunlight zone. Every single drop of water on the planet is completely habitable and bursting with solar energy. Section 3. The sunlight-drenched marine megacity. When you eliminate that freezing, dark abyss and bathe the entirety of your oceans in life-giving light, the consequences for biodiversity are literally explosive. It fundamentally changes what an ocean even is. We aren't just talking about a few more fish here. We are talking about living coral megacities that stretch uninterrupted for thousands and thousands of kilometers. Bordering these are impossibly dense, vibrant kelp and algae colonies that function essentially like underwater tropical rainforests. Because every single inch is perfectly habitable, there are trillions of animals fiercely competing for real estate. You'd see bizarre, highly specialized creatures evolving to fill every possible niche. Fascinating things like pseudo-crabs, massive fish lizards, and complex symbiotic relationships that would make Earth's Great Barrier Reef look like a quiet, empty puddle.
And this leads us to an unbelievable multiplier, 45 times. That's how much longer Hestia's coastlines are compared to Earth's. Why? Because Hestia is an archipelago world. Instead of a few massive, dry megacontinents like we have, Hestia is fragmented into millions of islands. In nature, Coastlines, where the land meets the sea and all those nutrients mix, are massive biodiversity superchargers. Multiply that edge habitat by 45, and you generate millions upon millions of new, distinct niches for species to evolve into.
Let's just slow down the pacing slightly to let the sheer scale of this superiority sink in. Earth, our supposedly perfect home, hosts somewhere around 9 million complex species. But Hestia, because of its larger surface area, its endlessly fragmented coastlines, and its entirely sunlit oceans, it could easily hold hundreds of millions of complex species. Hundreds of millions! The sheer scale of biological output on a super-habitable world like this proves that Earth is barely scratching the surface of what life can actually do. Section 4. Looking back at Earth. So we've built this incredible, vibrant, fully lit world in our minds. But what happens if intelligent life actually evolves in Hestia's perfect, sun-drenched oceans? How would they view the universe? Evolving on Hestia gives you a completely different perspective on reality, a perspective from a world of total light and absolute abundance. Imagine an advanced alien civilization native to this super-habitable world. To them, a thriving, globally connected, perfectly lit ecosystem isn't some fragile treasure, it's just the absolute baseline normal. Wherever they look, life is aggressively exploding. Their entire worldview regarding the resilience, power, and nature of life would be shaped by this overwhelming, unending biological surplus. Which leads us to a fascinating final thought. What would they think of our desert planet? If astronomers on Hestia pointed their telescopes at Earth, would they be impressed? Or would they see a world covered mostly in a freezing, crushing, dark, abyssal desert with massive landmasses trapped far away from water, orbiting a star that's already running out of time? They might just look at the cold, dark abyss of our home and say, yeah, no thank you, viewing Earth as an obviously inferior, really harsh world. It completely flips our perspective, leaving us to wonder just how magnificently bright and crowded the universe could truly be. Keep this in mind the next time you look at the ocean. Thanks for joining me on this explainer, and keep exploring the incredible possibilities of science.